Good morning. Today we will be comparing the linear and circular particle accelerators rather than electron accelerators in terms of the total radiated power by both these accelerators. We are not going into any other phenomena except the power output. We will be comparing the power output of both the accelerators, and let's see which one is better. So we start with the linear accelerator. In linear accelerator, the velocity and acceleration are collinear, and the total power output is given by the Leonard's formula, as we have studied earlier. This is the Leonard's formula. And since we know that momentum is equal to mass into velocity, and since we are dealing with the relativistic motion, so here it will be gamma times mass into velocity. I will be multiplying and dividing this velocity by c, so it will become gamma will be under root 1 minus beta. Now differentiating this with respect to time, I'll be differentiating this and converting it back into gamma. This is the same differential that we obtained yesterday. This will cancel out. Now converting this beta back into velocity upon c. Now this implies that I will substitute this value of v dot into the Leonard's formula. We define a quantity. This quantity, this is the classical electron radius, and we will substitute this in this for the value of this classical electron radius is 2.82 into 10 to power minus 15 meter. Now from the Newtonian mechanics, we know that force is the change in momentum, and in terms of energy, it is the energy change with respect to position. So using this relation, dp by dt is equal to d by dx, the power now becomes let's see, now we take circular accelerators. Here the power is given as we have already obtained this expression previously, and since for circular accelerators the velocity and accelerator are transfer acceleration are transverse, so this will be 0. So we will be left with only the first term. Substituting this back into the power expression, converting this dp by dt into de by dx, and substituting the value of the classical electron radius r0, I have substituted this. R0 is equal to U square by 4 pi epsilon 0 and C square. Let's write this circular and the previous one as linear. So comparing these two equations A and equation B, because this is P linear. So from this relation we can see that the power in circular accelerator is less and the power in the linear accelerator is more by gamma square. So as far as power output is concerned, the linear accelerator is of much importance for us, and therefore most of the particle accelerators being constructed nowadays are linear accelerators, in spite of the fact that the circular accelerators have a good resonance and relative compactness, but these linear accelerators are being preferred for particle acceleration. And the most recent ones are the plasma based linear accelerators, which have high power output and are compact in size. Like uh, uh, if we want to have a traditional linear accelerator, which will give us about 25 GeV of power, we will have to take about 15 kilometers in length. But for plasma accelerators, it will be a much shorter. It will be only 4 5 meters. We can achieve the same acceleration gradient. So that is why they are being used these days. So today we compare the linear and circular accelerators